Good afternoon, everyone, and welcome to today's webinar on improving safety in pharmaceutical production with hygienic flow measurement. But thanks for joining us. My name is Megan Parrish, and I'm the Senior Editor for Pharma Manufacturing Magazine, which is producing today's event. Today's event is sponsored by Burkert. Today we're going to talk about processes such as water for injection, or WFI, or clean in place, CIP, and discuss practical examples that will show how the surface acoustic wave, or SAW technology, can be used to gain filling time, improve quality, and reduce maintenance efforts. In this webinar, you'll get to know how this new technology meets the highest hygienic standards. Since there is no sensor element in the tube, the design guarantees that liquid is not contaminated. In addition, the flow sensor is able to measure several parameters such as flow, temperature, and density of liquid, and detect any bubbles in the liquid at the same time. Compared to conventional solutions, the SAW technology overall offers precise measurements and the highest level of hygiene to improve the safety of production, reduce the time and space needed for installation, and measure several parameters at the same time. Now, to complement this discussion today, we are going to have a live Q&A session at the end of the presentation. Please feel free to make note of your questions as they occur to you. We are also going to pause the presentation a couple times today to answer audience questions, so be on the lookout for that. Now, before I introduce our speakers, there are a few other housekeeping issues I need to review. On the interface we're using for this webinar, you'll see several different boxes or sections. The upper left or audio section allows you to adjust the volume. Just hover over this section until you see the audio volume control to adjust it. Below that is the Ask a Question box. Anytime during today's presentation, you can type your question for our presenters right here, and we'll get to your question during our Q&A sessions. And if you're having technical problems, you can also type in your question or concern in the Q&A box, and one of our technical engineers will help. Underneath the Ask a Question box is our handouts area. Here you will find additional information available for download. And in the largest section, you'll see today's presentation slides displayed. Below the slides, you'll also see a live chat box. This is a really good place to chat with other webinar attendees, but not a good place to put in a question for our Q&A sessions, because this isn't where we'll go looking for those. Also, you can enlarge a section by clicking on the square box in the top right corner of the section next to the X. Now, if you accidentally close out a section, don't panic. You can get back to it by clicking on the refresh button at the bottom of the screen. It's located to the left of the icon. Also, please note that this webcast will be archived. We encourage you to direct coworkers to the recorded presentation, and it will be available on the Pharma Manufacturing Magazine website. We've also recently added a Q&A feature to our on-demand presentation so that listeners can ask the speakers a question, and it will be passed along for them. One final note, we also ask that you respond to the feedback form at the end of this presentation. Your answers will help us improve future events. Now, I'd like to introduce today's speakers. Ron Shook is a member of the International Society of Pharmaceutical Engineers, Carolina South Atlantic Chapter Education Committee. At Burkert, Ron is the Industry Segment Manager of Water and Pharmaceutical Industries for North America and has an in-depth understanding of customer solutions, the competitive industry landscape, and trends in the global marketplace. Today, we're also joined by Hendrik Fostman, a product manager for FlowWave at Burkert. Hendrik is one of the co-inventors of the SAW technology and worked on developing the FlowWave. He now supports customers worldwide with integrating the technology into their applications. And with that, I will hand the floor over to Ron and Hendrik.
Thank you very much. Good afternoon, everybody, or good morning, depending on which coast you're on. My name is Ron Shook, and as she just mentioned, I am the Industry Segment Manager for our Water and Pharmaceutical Industry segment at Burkert, USA. A couple things to cover before we get into the presentation. We would like to welcome you on behalf of Hendrik and our Burkert team to talk about a very unique and innovative technology that will improve the safety in your pharmaceutical production. This innovative technology, or what you may hear referred to as FlowWave, is our flagship new product, and the implementation of this groundbreaking technology will improve your process from an efficiency, reliability, and safety standpoint. You may have noticed in the original invite that my colleague Andrew Lamore was going to be a co-host of this webinar with Hendrik. Due to some unexpected circumstances which require his immediate attention, he's unable to be with us today, but rest assured he's still a valuable member of the Burkert team, and he does send his deepest apologies. Let's get to know myself and Hendrik a little better. I'll begin to recite what's already been said, but I have 25 plus years in high-tech industries, including semiconductor, pharmaceutical, and food and beverage. Interesting little tidbit, in that 25 years, I've been an end user, serving various engineering, technical, and management roles. I've actually worked with a hygienic OEM, supplying equipment to the pharmaceutical industry. I've even worked for an architectural and engineering firm responsible for designing state-of-the-art flexible manufacturing facilities. And finally, my journey has led me to Burkert, where I am a solutions expert for all things flow. So with that said, I'd like to throw it over to Hendrik and have him tell you a little bit about himself. Hendrik?
Thanks, Ron, and hello from Germany. I'm Hendrik Faustmann, and my journey actually started with Acoustic when I was a teenager, and my uncle, he got some older loudspeaker from a theater or a concert hall from the city, and from this time, two friends and our dads, we restore this loudspeaker with new electronics and with new chassis, and build our own first sound system that was then used for private parties and private concerts. And actually that was also our start for the first business of rental these sound systems. After school, I studied physics, and I found a research institute about acoustics at the university. And that was the first time I heard about surface acoustic waves. And at that institute, we had the idea of developing a clamp protection system for car windows. So it was an automotive system that when the car window is closing, there is a sensor system detecting if there is a finger, a hand, or a neck in between the closing window and the door frame. And that we actually used an acoustic system based on surface acoustic waves to detect if there is something touching the edge of the window. So it was kind of a clamp sensor. And at that time, we investigated a lot about the interaction of the surface acoustic wave with different materials. And so we could realize that with the interaction of the surface acoustic waves and the different material, that we realized this clamp protection system. And from that time, we had deep knowledge about the interaction. So we thought that, hey, there is more, and we started to build analytical sensors based on this surface acoustic waves. And first analytical sensors we built was concentration sensors for liquids. And well, guess what we had first in mind as students for analytics? It was about beer and the concentration of alcohol and sugars in beer. That was working quite well. With these nice experiences, we started a company, a startup company, grew with the company, and started the cooperation with Burkert. And today I'm glad that I see this technology growing and this sensor helping successfully our customers at Burkert to solve their challenges in flow and as well in process monitoring. I'm really happy to see that, and I like to support you and the people to make their life better and easier. And I also like to create this product that helps to protect the environment.
Great. Thank you, Hendrik. That's quite an interesting journey. I actually learned a few things there, even though I've spent quite a bit of time with Hendrik, so thank you for sharing that. Before we get into discussing the surface acoustic wave technology and FlowWave itself, I'd like to do a brief overview of Burkert, just so you can understand exactly what we do in the pharmaceutical industry. So what you're seeing before you is a quick snapshot of Burkert's global organization, headquartered in Ingelfingen, Germany. Burkert has 36 subsidiaries around the world. You can read for yourself some of the numbers. There are a few things I'd like to point out that really drive home Burkert's business philosophy, our mission statement, and how we approach the markets that we serve. In the lower right corner, you'll notice a greater than 100% reinvestment rate per year. In a nutshell, what this means is we invest 100% of our profits back into Burkert, whether it's our business, whether it's research and development, or our people. Burkert is a very people-oriented company, and I can say with great certainty that it's been my pleasure to work for them these last couple of years. Another thing I'd like to point out is what you'll see in the top left corner, 5, what is referred to as system house facilities. System house is a German word for manufacturing, but basically these 5 centers of excellence are full service, full functional Burkert manufacturing facilities, housing not only manufacturing but engineering and design, the ability to build custom solutions, multi-component packages for our customers and our strategic partners. This also includes sales and service, as well as finance and accounting. Specific to the U.S. organization, our U.S. headquarters is located outside the greater Charlotte, North Carolina area in the city of Huntersville, North Carolina. Around 4 years ago, Burkert realized the need to invest in the U.S. market, and therefore they spent $30+ million on our flagship state-of-the-art facility located in Huntersville. Again, full service, full manufacturing, engineering design, parts inventory, as well as all our administrative support functions. With that said, I'd like to throw it back to Hendrik to get into surface acoustic wave technology.
Thanks, Ron. And here now you see me on a video recorded for a German online exhibition during the Corona time. And you see me with the flow wave in my hand. And here I want to share with you the highlights of the product. And one highlight is the hygienic design. You see, I was just looking through the pipe, and one big advantage of the flow wave is that there is no obstacles, nothing inside the pipe. It's really the straight pipe with stainless steel. That is something we were having in mind when we started that concept of flow wave, that we want to do a big innovation for sanitary applications, and our feedback in the market is that this is probably the best flow meter on the market supporting that hygienic design. Here's the next video from this online exhibition, and here you see on the video a closer look to the display of the device, of the flow wave. And here I want to share the second highlight of flow wave with you. It's about a multi-parameter sensor. So from this flow wave flow meter, you get the volume flow, you get the temperature, you get the totalized volume, and you get the density factor, the density of the liquid. And with the density, you can use that measuring value for diagnostic purpose or for process monitoring. So you directly see in that very repeatable density measurement if there is a change of liquid. One customer I was seeing the other day, they are using the density factor to see the phase separation from shampoo to water, and from that time they are using flow wave to detect this interface of phase separation between shampoo and water. They save more than 100 liters of shampoo every day, and that is really great to see that they can bottle now all these hundreds of liters more and get less waste and less shampoo in the drain for the wastewater treatment. Another value that FlowWave supports, that's actually on the second screen of the display, is the acoustic transmission factor. So it's about the acoustic transmission through the liquid, and this is sensitive and can be used for the detection of bubbles or particles in the liquid. So here you might have had this situation when you wonder if you have any air or any bubbles in your system. With the FlowWave, you now got the ability to detect if you have air or bubbles in a certain time in your system. And now in the third video, I want to share with you the performance of the flow meter FlowWave. Here on that exhibit, on the demo skid, we got it filled with water, and when I was opening the valve, I dosed water into that cup, and I can read that in that cup there were 200, a little bit above 200 milliliters, and that what you see on the screen is 206 milliliters in that cup. So you can see how precise this FlowWave works in terms of flow measurement. It's a very challenging installation. You see that flow from top to the bottom, what you usually don't recommend. And at the same time, you have a very fast and small amount. And that is usually very tough for flow meters to give a precise reading. And well, next time when we are allowed to have shows and exhibitions again, you can convince yourself on our booth. We will have it in the US. Then you can also dose your different liquids. Here it's with water, but you can also use it with coffee or with juice, or as well with beer or other drinks. On the next slide, here you see an example of an installation at the customer. And this slide is not to give you a recommendation for a good installation. Here it's kind of a worst case installation, but even under this worst conditions, we managed it that the FlowWave gives a proper flow reading. Here in this situation, again, you have a flow from top to the bottom. You have a 90-degree elbow right in front of the flow meter, and you also have an extension of the diameter. You come from 1.5 inch to 2 inch in diameter. So that is typically not what we would recommend. But anyway, what we did there with the customer is that we did a teach-in calibration. And with this teach-in calibration, the FlowWave is performing very good with giving very accurate readings. What I would also like to share with you on that picture is that flexibility on installation. So you can install it in a vertical way. You can also install it in a horizontal way. The transmitter with the display is giving you also a lot of flexibility. Here you see the display on the top. You can also mount it to the front of the sensor depending on the installation. And you can also turn the display in 90-degree steps that you always get a clear view on the display. Okay, so you have heard I'm an expert on acoustics, so I would like to introduce you to the surface acoustic wave technology that is FlowWave using for this measurement of the different measurement values. Here on this slide, you see a cut through the sensor. The light gray areas is the pipe wall, and in the pipe, in the blue color, is the liquid. And from the outside, in the dark gray color, there are the transducers. And these are special transducers dedicated for transmitting and receiving surface acoustic waves. They are called interdigital transducers, and these interdigital transducers are named because of a certain electrode structure that are dedicated only for a certain frequency and wavelength of the surface acoustic wave. And in this example, the transducer on the left, top left, is used with the triggering signal, so it's the transmitter. So it uses an electrical signal, and with a piezoelectric effect, the transducer starts to vibrate and generate with this electrode structure the surface acoustic wave. And basically, the surface acoustic wave is traveling along the pipe wall to get received on the top right transducer with the first wave group. We call that A0 direct. So this is the wave group that is only traveling along the pipe wall. At the same time, a part of this energy is also both converted, and it's traveling through the pipe, through the liquid, to get to the other side and reconverted as surface acoustic waves, and that's the green path, to get received on the bottom right transducer as the first wave group. So this is the path that is once traveling through the liquid. Again, a part of this energy gets reflected, and now it's the orange path I'm following to get reconverted on the top pipe as a surface acoustic wave and giving a second wave group in orange, and so on and so on. So you see a multiple reflection in that pipe that is using the law of total reflection. You may know it from optics, this fiber optics, where you use this total reflection to transmit optical waves, for the fiber optics for fast internet. This is using this total reflection of electromagnetic and optical waves. And here we use that same phenomena in acoustic with surface acoustic waves. And basically we get from one transmitting signal in two receiving signals, 6 received wave groups. And now you may wonder how we measure flow. For the flow measurement, we do a trick that we use on one pulse. We use this condition that on the left side we have the sender and on the right side the receiver. And for the next pulse, we switch the transducer that we have a signal coming from the right to the left. And then assuming that we have a flow from left to right, we have on the one hand signals traveling with the flow, that's downstream, and we have signals traveling against the flow, upstream. What happens that the velocity of propagation interfere with the velocity of the flow. The signals traveling with the flow are faster than the signals traveling against the flow. And from that difference, we can calculate the flow velocity and the flow in the pipe. And we can do it in a very accurate and precise way because we have this multiple reflections and this multiple path where we get the more often the signals traveling through the pipe, the more sensitive it gets to detect also small changes in the flow velocity. And the very nice thing is also that we got the signal along the pipe wall. You remember this A0 direct, and this is about internal reference for the flow measurement. So this is not sensitive to flow. This will give kind of a self-adjusting sensor. In the next slide, you see an animation of the propagation of the surface acoustic wave. Again, on the top left, you see the vibration of the interdigital transducer. Now you see the traveling of the surface acoustic wave along the pipe wall, and at the same time, the wave front crossing the pipe, reconverted as surface acoustic wave on the bottom side, and also now this reflection starts to get the signal back to the top. And again, seeing the vibration of the transducer, propagation along the pipe wall. And it's not only a beam, it's really a wave front traveling through the pipe. And here, imagine that there is some bubbles in the pipe. And of course, bubbles will kind of interfere with the technology, but it's not really sensitive, but it's quite robust, the behavior of the sensor with bubbles, because it's not only a beam that gets interrupted if there is a bubble. So you have really a wavefront that enough energy can go along even if you have bubbles within the liquid. Okay, comparing flow wave and the SAW technology with conventional solutions. And here for high accuracy flow, you find often Coriolis flow meters. The challenge here is that usually they are very large and very heavy. They are also complicated to install and configure. So you have to find the right place in your skid to integrate them. Also, you have some challenges on the drainability, that the flow, that the liquid can flow out of the device on their own. And comparing to electromagnetic flow meters and magnetors, that requires a certain minimum conductivity to work. So you cannot apply magnetors to all kinds of liquids. And with flow wave, comparing the size and the weight, it comes to a really compact. You remember the video when I had a flow wave in my hand. I would not be able to have a 2-inch Coriolis flow meter just in one hand. So flow wave is really compact and light. The installation is very flexible with flow wave. You can do it vertically, horizontally. It's just a pipe, so the drainability is solved and easy. And you can apply flow wave to all kinds of liquids independently on conductivity. So you can apply it for clean water, purified water. You can also apply it for oils. You can apply it for milk or chocolate, even high viscous liquids. That is a big advantage and a highlight for flow wave. In conclusion of the surface acoustic wave SAW technology, with flow wave we have one device and several functions. It's about flow measurement, and you get additionally a temperature measurement, the measurement of the density with a temperature compensated density factor, And that allows you to do process monitoring and to do also phase separation. And you also got the acoustic transmission factor that is to detect bubbles or particles in your system. The FlowWave is 100% hygienic design, no sensor components in contact with the medium. There's no empty space. It's simple cleaning. And the high performance you have seen in the dosing video with a precision of 0.4% of the measured value.
All right, thank you, Hendrik. At this point, let's talk a little bit about applications for FlowWave in real-life systems and manufacturing processes. So one obvious application, and this is something near and dear to my heart, is the generation, storage, and distribution, including points of use for water for injection. So what you see here is a typical water for injection system. For the sake of space, you'll notice that we more or less cut out the distillation or EDI UF system. So what's being shown is more pretreatment, but for the sake of the conversation, let's consider that the generation system. So in basic WFI system, what's important, especially in terms of batching, it's important to know the temperature. It's important to understand the flow, quite commonly the totalized volume. It's also important to understand and to know how water is being flown and at what rate throughout the various recirculation loops and distribution loops. The advantage of FlowWave, whether it be on the pretreatment side, whether it be or on the purified water / WFI side, is that it works just as well for conductive and non-conductive fluids. WFI, often refer to WFI applications as a slam dunk application for FlowWave. So what you'll see over the next few steps is how FlowWave can be of advantage across various configurations for point of use distribution throughout the manufacturing facility. Quick customer testimonial. This came from an infusion bag manufacturer who was doing a lot of manual filling with older flow technology. Upon designing a new system, they chose to go with FlowWave, both monitoring the batching process for the various infusion fluids as well as the filling process itself. They actually gained filling time by more accurately registering the fill volumes, by being more precise in terms of their batch processing, as well as the cleanability and the hygienic design of the unit. So we take this a step further and we begin to look at more of the WFI storage and distribution. What you'll see here is a configuration where you've got a FlowWave measuring the recirculation flow, and we're showing 4 what I would call subloops. At some point, these could be actually in the manufacturing suite, or they could be subloops that feed multiple areas of a larger facility. When coupled with our element control valves, this makes a good combination. And this is where I really want to bring in another aspect of FlowWave we've not really talked about, but the fact that FlowWave, in terms of control technology, is extremely sophisticated and what we like to refer to as Industry 4.0 ready. This is a smart device that has the ability to communicate digitally across multiple industrial Ethernet protocols, such as Ethernet IP, Profinet, and even Modbus TCP. The ability to utilize FlowWave with a comparable smart valve allows you to decentralize control and put it where it can make the most benefit to your overall system, even at the device level, to have the valve and the flow meter controlled together. It takes load off your PLC. It also allows each loop to make the decision at the appropriate level. And we'll talk more about that later on in the presentation. One thing I will point out too is that FlowWave is that our element topworks do come with built-in P&ID functionality, which would really allow you to do the decentralized automation. This is a more simplified version where we're only using one valve with a series of flow waves, same concept. For the sake of time, I know we're running close, so I'm going to get through this really quickly. And again, an even more simplified benefit. Another aspect I just want to point out is when coupled with our Robolox product, which is a multi-port, it's the ability to use a single actuator to direct flow across multi-ports. Think of it like a diaphragm block valve with a single actuator. We could actually manage multiple loops with flow waves with the Robolox design. And please, if you'd like more information on that, my contact information will be available at the end of the presentation. So at this point, we want to pause and allow the audience to ask a question. I think for the sake of time, we may only be able to address one question. So with that, I'll turn it back to the moderator.
Hey guys, this is Megan again. I'm jumping in. Just a reminder to the audience, if you have a question right now for our presenters, you can type your question into the Ask a Question box that's on the left-hand side of your screen. It's right under the audio box. I will go ahead and take a look at questions that are coming in, and we'll do our best to get to all of them today. I do have one question for either of you right now. Apart from WFI, can flow waves be used in other water treatment and purification applications? For example, purified water, clean steam, or pretreatment?
I'll field that one. Absolutely. I think there's an obvious, what I would call ROI for any instrument or component that you choose for a certain system. There's always just good enough in terms of pretreatment. A lot of people don't really consider that critical, although more and more facilities in terms of the quality system are starting to look at all aspects of the water treatment, whether it's pretreatment, whether it's the actual either distillation or final purification step in a purified water system. So depending upon the risk, how your facility approaches risk, flow wave can definitely be applied at any point along the water generation, storage, and distribution of WFI. In terms of clean steam, it would be, we actually have many customers who have spec'd flow wave for use on clean steam generators in terms of simple flow monitoring and control of the incoming purified water WFI to the evaporator and condenser assembly. So I guess long answer short, absolutely.
Okay, great. And I do have another question coming in from the audience now for you, either of you to field right now. This audience member is asking, will there be meters with remote display?
We do offer remote displays in many cases. I don't have any shown in this presentation. Hendrik, can you advise on the availability of a remote display?
Yeah, and it's a great opportunity to introduce. There is a new version of the flow wave, just came out, the flow wave S with a compact transmitter. And this allows you also a remote display. It's a very robust and compact transmitter with a digital interface where you can then use a remote monitor display. Yeah.
Okay, great. We do have a couple of other questions coming in, but I'm going to hang on to them for now for the Q&A section at the end so that we can get through everything. Audience members, if you submitted a question we haven't gotten to it yet, please sit tight. We will circle back to them. We do have a few more slides to get to, or get through rather, so I'm going to go ahead and hand the floor back over to Ron and Hendrik for now.
All right, thank you guys very much. I am going to go through this. I do want to be respectful of your time. I know we started a little late, but I want to be respectful of your time, so I may go through some of this quite quickly. If you ask a question or have questions and we don't get to it today, I'd be happy to take those questions and answer them in some written form to be able to send back to pharma manufacturing to distribute. So just keep that in mind as we try to get through this as close to on time as possible. So another application which I actually think is perfect for flow wave is clean in place. What you see here is a typical clean in place system. Again, somewhat summarized or abbreviated, but it kind of gives you a general idea of the basic components of CIP in terms of process equipment cleaning. The reason I like FlowWave in this application is because of its multi-parameter functionality, apart from just being a flow meter. So if we really want to look at a typical CIP system, we've got some basic steps that apply to almost all CIP systems, regardless whether it's pharmaceutical, food, beverage, dairy, brewery. So I'd like to kind of hit a few of those and kind of lay the groundwork for how FlowWave would function based on the process steps of CIP. You've got your pre-rinse to drain. After that, you've got a caustic soda wash. One thing with FlowWave, it's very good at detecting minute changes in what I'm going to call concentration. So it's slight changes, whether it be the caustic soda wash or the acid clean, it's going to be able to detect even the slightest change in concentration. And an added benefit, it's going to be able to give you some idea of entrapped air or bubbles, because I know one thing you have to worry about in CIP systems with detergents is foaming. I know we addressed that with the type of detergents that are purchased, but FlowWave would also be a benefit to be able to give you an idea of foaming as well. In terms of the rinses, whether it's the intermediate rinse 1, intermediate rinse 2, which follows acid clean, or the final rinse, because FlowWave is so good at measuring changes in composition of the fluid stream, we see this applied in a lot of cases as verification of acceptable rinse. Basically, absence of detergent or acid or other residue that may be in that rinse stream to drain. Basically, by using the dimensionless density factor, as Hendrik pointed out earlier, you're able to use that parameter, and in some cases, depending upon the accuracy required, you could possibly even use FlowWave's readout and convert to an actual conductivity value without the need for an additional conductivity sensor. Along those same lines, I'd like to point out that FlowWave's built-in temperature measurement may be a good option depending upon your application as an opportunity to reduce an additional temperature sensor or RTD in this case. It's very effective, a multi-parameter function in a single device. Couple that with its hygienic full bore design, and this is why I get very excited when we talk about CIP and the application of FlowWave. Again, we talk a lot about it being a smart device. The ability to communicate digitally. One thing that we also want to mention is with digital comes in a certain amount of data that becomes available. This data can be used to track and trend process performance, to look at potential failure areas, predictive maintenance. So the fact that it is a smart top, there is a lot of data which is configurable at your disposal. So again, we pointed out, this is just a repeat of the picture that Hendrik showed earlier. Obviously not an ideal design. We could always point out, we could all point out multiple things that are on this installation. But one thing I do want to point out here is the block valve itself that is underneath the FlowWave. This block valve was designed by Burkert with our actuators, which as an extension of our flow solution, we do offer a full line of custom block solutions, including one-off designs. So keep that in mind as you're looking at a system in general. Again, another customer testimonial in terms of maintenance. One, the fact that it is full bore technology. There's nothing in the flow path that can fail, including soft parts and gaskets. So in that case, it's relatively maintenance free. If you look at the diagnostics capability that the Smart Top has built in, You can use that a lot for predictive maintenance. And of course, the calibration aspect, it's quite easy to calibrate. The LED display has full functionality, which you can do everything that's possible on the FlowWave from a setup and diagnostics point of view through the LED display. It goes without saying too that the compact size and the relatively lightweight definitely makes this a one-person job. No additional heavy lifting equipment, hoists, or personnel are required for maintenance. So with that said, we'll open it up for some additional questions. Megan?
Yep, thanks, Ron. We do have lots of questions coming in from the audience. I have one that's a three-part question I'm going to throw at you, Ron, and we'll tackle this in three parts. The first part is, can the FlowWave be used in lieu of a conductivity sensor?
Good question. I did touch on that a little earlier and indicated that you can take the density factor value and convert that into a conductivity value. I guess my question would be, what does your validation say? Was it validated as needing more accuracy than potentially a calculated value could provide? I think that's an internal decision that has to be made in working with your validation quality teams.
Okay, sounds good. Next part of this question, can FlowWave withstand the high temperatures associated with hot water sanitation and SIP?
Oh, absolutely. I mean, this is, the basic construction of FlowWave is we start with a piece of ASME BPE tubing. And we never at any point penetrate the inner wall of that tubing to build the FlowWave. So the heart of the FlowWave is a common piece of stainless 316L that we then build around to come up with a final product. Electronics are adequately insulated from the surfaces that see the increase in temperature. So this was designed to operate at even the most extreme temperatures seen in a hygienic environment.
All right. Last part of this question, since FlowWave also measures temperature, how accurate is the temperature reading? Do you need a separate temperature sensor or RTD?
Again, I'll have to kind of give you the same answer I gave with conductivity. The accuracy of the temperature measurement in FlowWave is plus or minus 1 degree C. In some cases, that might not be tight enough based upon what's required as part of the original validate. What your process requires, basically. Your process may say that plus or minus 1 degree is acceptable. I think that's going to be a decision that gets made on an individual application level. Can it serve as a temperature sensor? Absolutely. Does it give you the accuracy you need to be the temperature sensor in the system? That's definitely a local decision.
Okay, great. And I know we've got just a couple more slides to get to and get through, so I'm going to hand the floor back over to you, and then we will wrap up with the Q&A session.
Great. So continuing on really quickly, I want to point out a few other technical specifications and aspects concerning FlowWave. Currently, FlowWave is available in sizes ranging from 1/2 inch to 2 inch, with a 2.5 inch and 3 inch version available before end of the year. We feel like this will give us a good range to handle some of the smaller applications as well as some of the larger WFI distribution systems that exist in some of the larger facilities. All FlowWaves sold in the U.S. come standard with electropolished internal surfaces. We electropolish to less than 0.4 micrometers or less than 15 RA. Standard connections, it comes like you see it here with standard ASME BPE tri-clamps. So no worries there as far as being able to put this in a system with ASME BPE tubing. It is UL listed. The housing is IP65-67 rated, which is in NEMA terms NEMA 4. interchangeable LED. We also offer a blind version if there's some concern on having conflicts between the display and, say, a readout on an HMI. We do offer a blind version. And again, we just had the question about the remote display, which I think with our new Model S, not a Tesla, we we have that capability. If you'll notice, there's a ring up here that's kind of showing a blue light. This is a configurable status light. It's multicolored and it is configurable. So you can actually program what green means, what yellow means, what red means, what blue or orange means. So it really helps you set some levels to communicate visually with your manufacturing personnel. We've talked a lot about digital interface with industrial Ethernet protocols. We do still offer a 24-volt DC version with a 4 to 20 milliamp output and multiple configurations of built-in digital inputs and outs and analog inputs and outs. Along those same lines, there are multiple electrical connection options, both in power supply as well as the actual connections themselves, whether it be a cable gland, whether it be M5, M8. So what I want to kind of bring that all together and say that if there's a specific need from that point, I would bet that we're able to meet that with a standard product. So let's recap. I know we've went through some of this quite quickly to try to recoup some of the time, but I want to hit a few points that we really want to drive home about FlowWave as you begin to consider alternatives to the way that you're currently measuring flow. If you'll notice, we made reference to safety at several points in this presentation. By safety, obviously personnel safety is of utmost importance, which is why we meet the Pressure Equipment Directive as well as all CE directives for this device, but also safety in your process, reducing risk, giving the accuracy and repeatability needed, basically eliminating the potential for contamination due to the presence of a flow sensor. So we bring that all around, and I think the word safety really drives that home. Regardless of the conductivity of the fluid, FlowWave can be used in both conductive and non-conductive situations. I noticed a question here about air bubbles. Hendrik, correct me if I'm wrong, but FlowWave can handle up to around a 40% cutoff of entrapped air or bubbles. So I think when you look at a pharmaceutical application, FlowWave would be more than suited to handle the applications that we've talked about and many more. We've talked about the added functionality that exists with the density factor and the acoustic transmission factor in measuring concentration and temperature. Again, a lot of questions on that, which I appreciate. And one thing that we didn't spend a ton of time on that I think we can drive home here is from a weight and size point of view, specifically when compared to Coriolis, traditional Coriolis. FlowWave is a fraction of the weight and the footprint of a comparable size in a traditional Coriolis. Let's talk about a 2-inch Coriolis or a 2-inch application with a 2-inch FlowWave versus a 2-inch Coriolis. A 2-inch FlowWave weighs approximately 8 pounds. In looking at various data sheets of various manufacturers, there are 2-inch Coriolis that can weigh as much as 150 pounds. So from a weight point of view, it takes it from being handled very safely by one individual to being a multi-individual installation or maintenance or removal, possibly even with some lifting assistance from mechanical devices. In terms of footprint, the 2-inch FlowWave is 9.8 long. It's 4.9 wide, which would be into the screen, is what we consider width. and 7.1 inches high. That comparable Coriolis, and this is the smallest one I was able to find across multiple manufacturers, is 22.1 inches long, 7.8 inches deep, and 17.5 inches high. So I think even without doing a volumetric calculation, it's very obvious that the weight and the footprint advantage definitely goes to FlowWave. So, in closing, on behalf of Hendrik and the Burkert team, I'd like to thank you for attending our presentation today. I know our schedules have been busy as we all kind of get back into more of a routine coming off of COVID, but I also understand that working from home has its challenges too, with family responsibilities and such. So it means a lot that you would take the time today to dial in, listen. We're getting a lot of questions, participation. We greatly appreciate it, and we hope that you would not hesitate to reach out. What you see here is my contact information. If you've got a question for me or for Hendrik, feel free to contact me, and I will make sure I get that answer. One thing too is in terms of our Burkert sales channel, we have our area sales managers are located in strategic territories around the U.S. So even if it's getting connected with your local area sales manager, I can definitely assist with that as well. So again, thank you for your time. I apologize for going over, but I'm glad we were able to get through the presentation, and I wish everyone a great rest of your day.
Okay, great. Thanks so much, Ron, and thanks so much, Hendrik, for that thorough presentation. As Ron mentioned, we are getting a ton of questions in from the audience. Unfortunately, we are running out of time, so we're not going to be able to address them all, but everyone, please rest assured we will pass along the questions and your contact information to Ron and Hendrik so that they'll be able to follow up at a later time. But we do have time for one question. So for either of you, this question is, what pipe sizes is the FlowWave available in? Ron or Hendrik?
Specifically, we have 1/2 inch, 3/4 inch, 1 inch, 1.5 inch, 2 inch available now. By end of the year, we'll have 2.5 inch and 3 inch.
Okay, great. So again, everybody, thank you so much for tuning in, and thank you so much for submitting all those questions. Again, they will get passed along to Ron and Hendrik so that they can follow up at a later time. Ron, thanks for fielding all those questions, and Hendrik, thanks again for it. It's a great presentation. Just a final reminder to our audience, please let us know your thoughts about this presentation by answering our brief survey. It's going to appear on your screen shortly. Your candid answers are appreciated, and they do help us craft future events. Please remember that this webcast will be available on pharmamanufacturing.com. You can log in to view it again or share it with your colleagues. We also encourage you to visit pharmamanufacturing.com to gain access to even more tools and resources aimed at helping you achieve on-the-job success. So on behalf of Pharma Manufacturing Magazine and the folks at Burkert, thank you so much for your attendance, and have a great rest of your day.